Hello everyone, welcome to Prakash IT. So, in this tutorial, we are going to learn about OOPS in Java, OOPS concept in Java. So, I can say OOPS concept Java is the important feature as part of Java we are going to study. Okay, so in this video, what I am going to explain is I am going to explain all the OOPS concept, that means OOPS feature along with the examples. So, we are going to cover in-depth knowledge as part of OOPS in this video. So without wasting much time, let's get started. Okay, so let's talk about what is the agenda of today's video. So what are the topics we are going to cover as part of object-oriented programming, that is OOPS. Okay, so we are going to cover who needs OOPS and why, what is OOPS, the second things. Once we understood who needs and what is OOPS, then why do we need OOPS? So what is the things that will help while developing our application? Why do we need OOPS? That also we are going to learn about this video. And what are the important pillars of OOPS? What are the important pillars of OOPS also we are going to study. So I will explain what are the pillars that is there as part of OOPS I am going to cover in this video. And features of OOPS, what are the features, that is also the pillar, but I can say like what are the other features that is there as part of OOPS. I am going to explain in detail, in depth, I can say. I will explain the concept in depth. So with examples. Okay, don't worry, listen carefully, I will explain everything here. So before jumping into the agenda, like what is OOPS, why we need OOPS, what is the importance of OOPS, what is the advantage of OOPS. Okay, before explaining, so let me tell about the background. Actually, who needs OOPS and why? So I can say, if you are a student, you are you are studying, then if you are going for the viavas, you will definitely, whoever is a student, they will go to the viavas at the end of the semester. So in that time, definitely I am 100% sure the person who is going to attend the viavas, then he or she definitely will get the question regarding OOPS. So the interviewer, I can say, the person who is taking the viavas, he or she will ask, can you please explain me regarding OOPS? What do you mean by OOPS? With example. Simple. So for the who is doing the academic, who is studying as part of their academics, definitely it's a must and should questions. Not only for the students, it is also a must and should question for the freshers as well as experienced professionals who are preparing for the interview point of view. That is also, this is also a must and should concept you should learn. So as this is a very important concept for everyone, so everyone should give a special care while studying OOPS concept, specifically OOPS concept. Okay, while designing the application, what are the factors we need to take care while implementing the while developing the application by using the OOPS principle, that we need to give special care. Okay, so it's time, let's understand who needs OOPS. I have already told. Okay, so everyone should everyone should give their 100% while studying about OOPS. Okay, so what are the questions, you are going to encounter whenever you are going for an interview, whenever you are going for a bus, everything, like you are going to get these kind of questions. I have listed down. I will show you and explain what do you mean by OOPS. If, can you please explain me what is OOPS, what are the advantages of using OOPS, what are the main four pillars of OOPS with example. Can you please explain all these things? Interviewer is going to ask all these questions. Okay, if you are unable to explain the OOPS concept itself, then you are done for the day. Okay, so you will not get a job. Okay, so there is no need to go further. Okay, if you don't know OOPS, then you don't know anything as part of Java, I can say. Okay, so please give a special care while learning this OOPS. Okay, so why do we need OOPS? Okay, let me explain with a layman point of view. Why do we need OOPS? OOPS is something, for example, we have seen, we are going in the going on the street, then we saw someone is take an example of dog. The dog is is just going on the road. Okay, you saw. Then what the things will come into your mind? This is a dog. This is a this is a real world object. Real world object. Okay. So a dog having four legs, 2 ears, two eyes. So this is the I can say this is the real object in the real world. Okay. So, but our objective here is to learn about OOPS. So I can say to convert the real world entity into the programming world. Okay, that is the job of OOPS. Why do we need OOPS? For example, let me take one example. I can say whenever we have seen some real world entity. For example, take an example of a dog. Okay, a dog. We can think of a dog that is a real world entity. Whenever we saw a dog is having four legs, two eyes, 2 ears, something. Okay, the four legs, two eyes, all these are properties of the dog. So how we will write in the in case of program? So let's take a class. Everything we will consider in OOPS, in object oriented programming, we will consider everything as a class and object. We will convert everything into class and object, then only we will able to work on the principle of object oriented programming. Okay, so in Java everything is class and object. In terms of class and object we have to convert, then only we will get we will reach into our goal. Okay, so everything what we are seeing in the real world, I have given the example of dog. What we will do, we will write a dog class dog. Okay, if you are new to the Java, I am giving the example. So the prerequisite for this OOPS is you must and should have some knowledge, at least basic knowledge. You should have knowledge that what is a class, what is an object, what is a method, what do you mean by parameter, what is the parameter or argument, whatever the arguments we are passing to the method. These things, what is the return type. Okay, whenever we have method, it should return something or it may not return something. What do you mean by return type? These types of basic things you must and should know. If you don't know somewhere something like going through this OOPS concept, I will explain. But if anything I have left out, please let me know in the comment section so that I will address in the upcoming video. Okay, so let me concentrate on this today's topic, that is OOPS. Okay, I'm considering all of you know at least the basic things, so that it will be easier for you to understand this topic. Okay, so as I told, to convert the real world object into real world entity into the programming world through OOPS, we can achieve that. Okay, so let me just write one sample class. Okay, let me take one example called class called dog. Okay, let's call we have a dog class. Okay, dog is having some property int legs. This is the property, and a dog is having some color string color. Okay, dog, this is the property. This is the two property I have for the dog class. Okay, so dog is having something, some action his dog is performing. Maybe I can say dog is performing some action called eating. Eating action dog is performing. So I so to write the action, for that we can say these are called as method in Java. The action which the dog is performing, that is eating. Eating is action, right? So that is a that is what we called in called as method in Java. So I can say void method name is, right, eat. It is the method. Dog will eat, right? So what I can say, this out, dog is eating. Okay, dog will eat, right? So what I have given, this is the method, this is the action in dog is performing, and this is the two property the dog is having. Okay, let's go back. I have told why we need oops. I consider that we have a real world entity which I have written as part of programming. We have thought about the dog class, and I have written that dog class as part of program. Okay, so I converted the real world entity into the programming world. This is just a basic. This is I can say this is the start. Okay, so many more things are there we are going to cover. Okay, let's see. So by writing the code, by following the OOP principle, what we are going to achieve is we can write the simpler code, and the maintainability, and for the modification of the code, and the debug. If something went wrong, we can debug the code easily. I will explain, you will understand by going further. What we are going to achieve is we are going to get like whenever we are writing the code by following the OOP principle, then it will be easier to maintain the code, modify the code, and debug the code. That means OOPS concept will make our life easier. Okay, and by following the OOP principle also, we are going to reuse the code. Whatever the some principles are there as part of OOPS, I will explain by, but just remember that by using the OOPS, what we are going to achieve is like we are going to reuse the code. That means for a set of action, we are not going to write the same code again and again. What we are going to do is like we will write the code one time, and in multiple places we are going to reuse the code, same code. That is the feature of reusability. If we are going to use the same code in different places, then we can say that we have achieved the reusability feature of OOPS. So that is a feature of OOPS. We can reuse the code. Okay, I have already told this point. Then what do you mean by OOPS? So uh, we got some idea like why do we need OOPS, and who needs OOPS? What is the if we are using OOPS, then what are the things we are going to get? These things I have discussed. Then we are going to learn about what is OOPS and what are the features. Okay, so one after another we are going to discuss in detail. Okay, so what do you mean by OOPS? OOPS, I can say OOPS stands for object oriented programming. This is I am telling from the zeroth level to I'll go to the higher level, so it will be easier for everyone to understand. I am giving this lecture by considering for the from the students to experienced people. Okay, so everyone should give a special care while learning this video. Okay, so let's understand why, because this is a very important concept, that is why I am stressing much. Okay, so you should give your 100% while learning this oops concept. Okay, so what do you mean by oops? Oops stands for object oriented programming. You should know object oriented programming. What is that? What do you mean by object oriented programming? Object oriented programming is a methodology, it's a principle. By follow that, what we can do, we can design our applications by using the classes and objects. In terms of class and object, we are going to use object oriented programming. Okay, clear? Okay, then what we are going to achieve is readability, reusability. So if you are going to follow the some uh, structure, then our code readability is going to improve. Reusability also we are going to reusability also going to improve. I have already told this point. Okay, then what, why do we need oops? So I have already discussed what are the benefits of oops. If we are going to follow this oops principle, then I told we are going to get the reusability feature. Our code will be simpler, debugging will be easy, and maintainability will be easy. So I have for this I have already told. So let us consider the real-time example. Say computer, car, employee. All these are real-time example. I remember, like I have given one example of dog. You remember, right? So similarly, for example, we saw in the real world what we are using. We are using a computer. We are using car. We have employee, right? So for this is a real world entity. So how we will convert into the programming world. So what we will do, we thought of computer. We have a computer. Computer is having some hard disks, some RAM, some disk size, right? All these things a computer has. So what we will do, how we will write this in program? So we will write class computer having some property, hard disk, something like that. We will write. So I have written the class computer, and what are the property methods, whatever we want to write, we can write just like this. Class computer, some code, and class employee having some. I have already wrote this code, right? You can imagine. So this is a logical entity. Okay, whatever the class we are writing, class is nothing but a logical entity. Okay, that is not real, I can say. Okay, now but we have understood the basic understanding. We got the basic understanding what is oops, what are the benefits we are going to get if we are going to follow oops. Then I have given the introduction of the class, why, and how to convert the real world object in real world entity into the programming world. Okay, that also I have given through one simple example. So now it's time to explain oops feature. Okay, so in this as part of this oops feature, we have this is listen carefully, this is very much important. This is the concept you are going to explain to the interviewer or to the who is taking the viavas for the students, right? The faculty. We are going to explain the faculty or a interviewer, wherever, like this is the important things you are going to explain. So give a special care while giving this whenever we are going to explain this feature, you have to be bit careful. Okay, so what are the, let me tell what are the features we have as part of oops. So oops is having six things we have. I can say oops is having the features like class. First of all, we have a class. Okay. Then from the class, we can create object. Object is a feature of OOPS. And then once we wrote the class and object, then how we are going to hide the information, important information. That is what is called abstraction. I will explain in detail, but I'm writing down all the features. Then I will explain one by one. Okay. So abstraction, and another one is encapsulation. How we can make all together all the members of the class. How we can wrap into a single unit. That is what is called encapsulation. Okay. And then the next property is important property is inheritance. How we can make the relationship between the parent and the child class, that we are going to learn as part of inheritance. Okay. And last one is polymorphism. Whenever we are writing some actions, right? That means we are writing some methods in a class to represent some action this method is going to perform. What is the job of method? The job of the method is some code or some logic we are going to write as part of method. Okay. So each method will perform some kind of action. Okay. So if same method having performing one action and same method at some point performing some other action, then that is what it is. The same method is performing two things. Like for some point of time, like it is performing some operation, and at some point it is performing some other actions. So that is what called polymorphism, but we are going to learn polymorphism in detail. Now let's start with class. So what do you mean by class? The first question it will come as like what do you mean by class? So class, I can say in Java, class is a logical entity, right? It's not a real entity. So we can think of, for example, let's take an example. We want to build a house, right? So before building a house, what we want to do? Before building a house, what we want to do? We want to create the architecture for that house. So before building a real house, what we can say? We have to create one architecture diagram for building a house, so that we can create not only one house, many houses we can create on top of the based on the architecture diagram. Okay. So the architecture diagram what we build for the real house, that is nothing but called as prototype or a blueprint. Okay. Similarly, in Java, class is nothing but as a blueprint from which we can create the object. Okay. Let's take an example. Okay. So I can say class is not a real world entity. Class is a logical entity. That means the real existence will not be there. Only blueprint we can imagine. Okay. Out of the class we can create the object. Okay. That is the job of the class. For example, in case of Java, let's take an example of employee. We want to clone employee. Employee employee is having some employee ID, employee name. Definitely, employee, if employee is there, employee should have one ID, one name, email address, something, some property employee class should have. So in order to build the class in Java, what I can say, we will create one class which is nothing but the logical entity. So we will write the class in Java by the keyword class. I will tell you the what is the syntax for class. So before that, let me tell what is a class. I already told class is a logical entity. So based on that, we can create, based on the class we can create the real object. We have created the class employee. From the class employee, we can create the employee object. I will tell. I will tell going forward. Like I will tell what is a object, how we can create the object from a class. So let's take an example. uh, we want to build a house. Okay. So this is the diagram I have kept. The architecture diagram is nothing but a blueprint for the real house. I have already spoke about this. Okay. So what we can say, we can build real houses from this architecture diagram. It is a blueprint for the real house. Okay, in the real world. Okay, so in Java I told a class we can create, we can write the class by using the keyword class, and a class will have some properties, method, constructor, all these things. Typically a class can contain, a class may contain fields, methods, constructors, all these things. Okay, methods, fields are nothing but we can say properties. What are the properties of a class, right? And methods in Java we can also, we are also can tell that we can say method is nothing but a behavior. For example, let me take another example. Let's say we have a dog class. Dog is having some legs, right? Dog is having 4 legs. So leg and dog name. What means dog? What is the type of the dog? Various types of dogs are there, right? So what is the type of the dog? What is the color of the dog? These are the properties. These are the properties, and the behavior. What is the behavior of the dog? Dog can bark, right? So dog can run. So um, no, the dog is making some sound, right? Make, we can write make sound in third. That is nothing but a behavior. Okay. So what a class declaration consists of? A class declaration consists of modifiers. Whenever we are writing a class, we will write public class, or we may not write public. If you not write the public keyword, then it will be, class will become the default. Okay, I will tell you how to write the class and how to create the object. But let's understand what is the concept behind it. What is meant by modifier? You might have heard that public, protected, all these things. But in case of class, what we can write? We can write only public or default for the class. It is applicable for the class. Okay, and whenever we are running the class, we have to use the keyword class. By using the keyword class, we can create the class. Okay, and followed by the class name, which is the class name should be, by convention we should write the first letter as a capital letter. Okay, for example, we are writing the employee class, public keyword class, then class name for employee, E should be capital. Okay, and super class means I will tell everything regarding the super class interface, all these things in inheritance. Whenever I teach the inheritance, then at that time I will explain in detail. But for the time being, you just remember uh, super class. If any class is what is that inheriting from any other class, then in Java, how we can achieve that? In order to achieve that, we can write our class employee. For example, it's a dog class. Dog class. Dog class is inherited from the animal class. Dog is a type of animal, right? So what we can do? We can write dog extends animal. Okay, I'll let you know in the ID, so that you will get a better clarity. Just for your information, I'm telling. So we can write, if any superclass is there, we can write the key by using the keyword extends. We can write that. We can write that class. So whatever the, for example, A class is there, A class extending from B class, so we can write class A extends B. Then we can write that. If any interface is there, for class we will use external keyword. For the interface, if that class is inheriting from an interface, then at that time, instead of extend, we have to use implements keyword. Okay, so the keyword we have to use it implements, right? And inside the class, once we wrote the class definition, then what we have to do? We have to, whatever the body we have, we can put inside the curly braces. That is the typical a class declaration consists, right? Now this is the syntax for the class. Class is having some access specifier, then keyword class, then followed by class name. And inside the class, we'll write the curly braces. Inside the curly braces, we'll write the class variables and class methods, right? As I told. Okay. So I'll tell, for example, consider the example calculator. We have a calculator class. So let me show in the id. Let me create, let me write a class, some calculator class. For example, calculator class. Okay, we have a calculator class. What I have written, it's a class, public class. I have written the class calculator. The name of the class is calculator class. So I want the properties or um, instance variable, instance variable. A calculator class may have some instance variable. For example, int a, one instance variable, and int b, another instance variable. And let me write some like the constructor. A class may have constructor, right? If you don't write the constructor, uh, whenever you will compile your class, right? So at that time, compiler itself will add the default constructor to your class. So here I'm going to add one constructor, parameterized constructor. Parameter constructor means a constructor which is having some argument. I think you might have studied before while right, the constructor, while studying about the constructor, right? So let me tell you, this is a parameterized constructor. Constructor is same as, constructor is having the class name, constructor is having the name similar to same as class name, and the access specifier should be always public. And whenever we are writing, okay, for the time being I'm telling, like, it is taking two arguments, integer a and b of type int. Okay, what is the job of constructor here? So the job of the constructor in Java is to initialize the objects, right? Whatever the object we are going to create, through constructor we are initializing the instance variable, right? The here the calculator class contains two instance variable a and b. Here through constructor, what we are doing, we are initializing this constructor. Okay, now here I'm showing what a class contains. So that similarly I'm writing, so a class may contain behavior. Behavior means method. I can say method or behavior. Okay, behavior. A calculator class, let me take one sample thing. Int add is a method. Int add a method, it is taking the argument a and b. Same a, okay, not argument, only like, make it simple. So a and b add. So what it will do, it will return something, because the return type, this add method is int, so it should return something. What we will do, we will simply add a and b, and the addition, the result will return. Okay, this is the uh, what I have written. I have written one class called calculator. I have taken two instance variable. This is the instance variable, okay, or member variable, and I have written the constructor of the calculator class, and I have taken the method or behavior, one method called add. Okay, so now let's come back. So now it's a time to know about object. I think you got a brief idea about the class. Now let me tell about the object. Object, I have already told, we have written the blue, that is nothing but a class. From class we can create multiple objects. For example, we have written the calculator class. From the calculator class we can write, we can create multiple calculator objects. Okay, so calculator object, what we can do, calculator class, if we create the two objects, so by using two objects we can perform some operations, like we have add method, we can add with two arguments 10 20, and the second object we want to perform some like 20 30 with the arguments we want to add. So we can perform multiple operations. But in case, I have already told, uh, the house, right? The architecture we have created. From that house we can build the real object. Real object means real house. Okay, so class is the logical entity, but object is the real entity. which is having some existence. You have created the architecture diagram, which is a pen and paper you have created, right? Then you are constructing the real house, okay, through the cement, rod, or sand, everything. So that is the real house, that is having some existence, right? So that is why object is called real entity. Okay, object are always called the instance of a class. So we are creating the instance, from the class. That is why it is called the instance of a class. Object is called the instance of a object, instance of a class. Okay. So if we have an employee class, from employee we are creating the object. That means we are instantiating the employee class from the we are instantiating the employee class. Okay. So what we can what we have learned, class, what is a class, how we can write the class. Now we are explaining what is a object and what do we mean by instance. Instance is nothing but the nothing but objects are called the instance of the class. What do you mean by object? Object is nothing but the instance of the class, I have told. So I will explain through id how we can create the object of a class. Okay, so I have already told. Similarly, I have told for a class what a typically a class may contain. So similarly, what a object consists of. Object is having some state. We are writing the properties of a class, right? So whenever we are writing, whenever you are writing a class having some property, whenever and again we are creating the object of that class, then it will have some state. Okay, the whatever the attribute of that object is there, that represent the states. Okay, and behavior means I have already told in Java, methods are called behaviors. So behavior is nothing but it is represented by the method of an object. Okay, and identity, whenever we will create the identity, means what? Identity means we will create the object. To hold that object will refer with a reference variable. I will let you know. I will create the object and I will tell the identity. What do you mean by identity? Every object is having some identity. And for example, we have created object 1 obj1, that is one identity. And object 2, for example, obj2, object 2, it is having object 1. We can identify the object 1 by obj1, and object 2 we can identify by obj. That is nothing but identity. Okay, and then method, I have already told. Method, why we use method to perform some specific task, we use method, right? So these are the things a object may contain, right? So now this is the time to learn how to create a object of a class. I have already told, from the class, from the whatever the blueprint we have, it may be employee, it may be a dog, it may be a house blueprint, house architecture diagram. From that we want to create an object. That is the real-time example I have told. And in Java, how we can convert the real world object into the programming world, that is the job of the oops. I have already covered that, right? From the in the beginning I have told, oops is nothing but we are using oops to convert the real world object into the programming world. Here the thing is that how to create the object. So in Java there is a keyword called new. Through the new keyword we can create the object. Okay, I will explain that. By using a new keyword we can create the object of a class. Okay, just remember, by using a new keyword there are various methods we can create the object, but the preferred way to create the object is by using the new keyword. Okay, just remember that the way. So we want to create the employee object. What we can write? Employee is equal to new employee. Whenever we are writing new, then that means we are trying to create the object. We are trying to create the object of employee. So what we are writing? We are writing new employee. That means we are trying to create the employee object here. Okay, and I have told we have the blueprint of the house. So architecture diagram I have already shown. I have already shown. So from that architecture diagram, whenever we build some house, it will look like the object is look like something like this. This is a real house. We built from the architecture diagram, right? From the architecture, before constructing the house, we can think of like this is the real house we built. Similar to this, we have the one class. From the one class, we can create multiple objects in Java. But in real time, what we can do, we have an architecture diagram. From the architecture diagram, we can build several houses or not? Yes or no? Yes, yes, we can create multiple houses from one architecture diagram. Once we have that architecture diagram, this kind of houses, multiple house we can create, right? Similarly, in Java, we can write the class employee. From the employee class, we can create multiple employee objects. Okay, fine. So this is the typical employee I have taken. Let me go switch back to the ID uh, to explain you. So I have written this calculator, right? Calculator class. Let me now write the test class for this. Class. You can write. I am writing down the line the test class. Okay, I'm writing the test class here itself, but you can write like calculator. I have written another example, so you can create the test class down the line also. But here to explain, demonstrate here, it will be convenient to understand you. That is why I am writing here. But for the better practices, like best practices, you can what you can do whenever you are writing, you can separate the class itself. But I'm for the demonstration purpose, I'm using both the class here to demonstrate you. Okay, so we can write the main method to, from where the execution will start. What is the job of like what we want to do? We want to create the object. How we can create the object? We have the calculator class. The what we can do? We are trying to create the object. So calculator, this is the calculator is equal to new. By using the new keyword, we can create the calculator, right? Calculator. Why it is giving error? Just understand, because this calculator we have created the constructor. This is nothing but the constructor call we are doing while creating the object, right? This constructor is expecting two arguments, int a and int b. Two arguments it is expecting of type int. So what you can do, you can pass two integer type. So for example 10 and 20, I'm passing 10 and 20. So the now the issue gone, right? Why? Because it was expecting two integer type, two integer. So since I have provided that, the issue gone. So now what we want to do, we want to calculate, right? We want to call the method. Once we create the object, on the object we can call this class member, class methods or behaviors we can call, right? How to call that? Calculator, we can call a method by dot operator. Calculator dot, once you type the dot, then it is coming the add method. So so whenever we will create the object 10 by passing 10 and 22 argument, what it will do, it will call this it will create this like it will initialize this instance variable, right? Okay, so 10 is assigned with a is having value 10 and b is having value 20. Whenever we call this constructor, means whenever we will create the object. Okay, so then we are calling this method add method. What it will do, it will add this a and b, and after that, after adding that, it will return. So what we want to do, we want to hold that result. So what we'll do, we'll declare int type variable, because it is returning the add variable. Add method is returning int type int. It is returning after adding a and b. It is returning int. So what I have done is I am holding that result with the int variable, right? Int type result. So just I want to print. Okay, just a dummy message like addition. Addition is equal to some result, right? result. So let me run this. Yeah, so you can see addition is 30. We got the addition is 30, right? So up to this, I have explained what is a class, what do you mean by class, what is a object, what a object can consist, what a class can consist, how to create the object, and what is the example real. I have given the real-time example, right? How to correlate the real object, real time, like whatever the in real time, whatever the object we are seeing, how to convert into the programming world. I have given the example of creating a house from the architecture diagram, how to create the house, and again from the I have written the calculator class. In daily life we are using the calculator, right, to calculate something. So how to create that object by using a new keyword, everything I have given the with example, right? Okay, so now it's a time to move on to the next topic, right? So I have explained these things. Class and object. The features, we have the features like class, object, inheritance, polymorphism, abstraction, encapsulation, all these things, 6 things we have. 2 things we have covered. Now is a time to discuss what are the 4 pillars of OOPS. The 4 pillars of OOPS are nothing but one is abstraction, encapsulation, inheritance, and polymorphism. For the working with OOPS, you have to have knowledge of class, object, abstraction, encapsulation, inheritance, polymorphism. You have to be give your 100%. You have to give a special care while working with OOPS. Okay, so without OOPS, you cannot you can write a you cannot write a application also, right? In a single class also. Why? Because in real time we are going to use this concept frequently. Without OOPS, our day will not complete, right? I can say. So now it's the time to discuss what is abstraction, what is encapsulation, what is inheritance, what is polymorphism, and how we are going to use while designing the application, while writing the applications. What are the rules we are going to follow while writing the while working with abstraction, encapsulation, inheritance, polymorphism. We are going to learn in detail with example. Okay, so let me explain one by one. Now, what do you mean by abstraction? Abstraction means what? Abstraction means hiding the details. In Java, what I can say, whenever we are trying to hide something, we can make use of abstraction in Java. That is the layman term I have explained. So what do you mean by abstraction? Means to hide something we can make use of abstraction. So how we can achieve that? So in Java, what we want to show, what we want to hide. Abstraction means we want to hide. What we want to hide in Java, we want to hide the implementation details. For example, you have not. I am 100% sure you have not understood anything till now. What do you mean by abstraction? What to hide, what to show? You have to say whenever you are writing a class, you are writing some behavior, some functionality of that class. For example, we have a shape class. We want to draw something. How you want to draw, that you don't want to show. Only the purpose, you know, this is a shape class, it is going to draw, but how you want to draw, that part you are hiding from the user. Clear? I think some idea you got. Abstraction. Abstraction means hiding the internal implementation, only showing the, what is that? Only showing the what is the functionality? What is the functionality we are trying to this class is going to perform? That part we are going to display to the end user by hiding the internal implementation. Let me take another example. For example, you are trying to drive a car. Whenever you saw something in front of you, whenever you are running, you are driving the car, another you saw there is a road jam. What you are going to, you saw something in front of you, whenever driving you saw something in front of you, in front of car. So what you are going to do, you are going to apply brake, right? So you know, if you apply brake, the car is going to slow down. Okay, but you know the only the external, or what is the implemented, what is the job of the brake, but you don't know how the brake is actually working internally. Okay, correlate, I'm telling, correlate with the real world. Whenever you are applying the brake, you are hiding the means the internal implementation, how the working principle of brake, that is that is hidden from the driver, right? Similarly, in Java, we are having a class. What will show only trivial, whatever the trivial means, what is the necessary things, only that we will show to the end user, and will hide the internal implementation from the end user. I think this is clear. Abstraction is clear. And abstraction, data abstraction is the property by virtue of which only essential details are displayed to the user and hiding the internal implementation or implementation details. I have already explained with examples. I think this concept is clear. And in Java, we can achieve abstraction by abstract class or interface. These are the two things by which we can achieve abstraction, right? We can achieve abstraction by two ways. One is abstract class, another one is interface. Through abstract class, we can achieve partial abstraction, and through interface, we can achieve 100% abstraction. That means, what is partial abstraction? What do you mean by 100% abstraction? I will tell. I will let you know. Just understand, I have explained what is abstraction. With example, I have explained what is the job of abstraction, and now I am explaining how to achieve abstraction in Java. And in Java, we can achieve abstraction by two ways. That is by using abstract class and by using interface. By using abstract class, we can achieve partial abstraction, and by using interface, we can achieve 100% abstraction. And let me explain what do you mean by abstract class. Abstract class in Java. Abstract class in Java is similar to is nothing but a class. Abstract class is a class which is declared as abstract. When I have shown you how to write a class, right? From class name. So before that class, we have to write. If you write the keyword abstract, then that class become abstract class. Okay. And what is the difference between the class and abstract class? Okay. So in class we are writing this simply a class name. Then in case of abstract class, what are writing? What we are writing? Abstract keyword, then class, then followed by class name. Okay. So in abstract class, what are the things that should be there inside the abstract class? Okay, I will tell you. It can have abstract and non-abstract methods. Whenever we are working with abstract class, so the abstract class may contain abstract methods. I have shown you the example of calculate class. In that calculate class, I have shown you we have a method. Let me show you that. Okay, we have the method called add. Add is a method. This is a concrete method. Why? Because in abstract is not there. We are not writing abstract int. If you write abstract keyword before this method, then that method will become the abstract, and abstract method uh, will be written without any body. This is inside the curly brace, we called it as body. Okay, so how we will write that after class? We will write the after class as uh, with this let me write that. Okay, for example, this is a class. After class, we can write this abstract method int. Okay, So we have to make this class as abstract. Okay, this is the way we can write, we can create that abstract. See, whenever we wrote this class is abstract, and we are it is crying. This is crying. Why? Because another thing I want to tell here is we cannot. We are trying to instantiate. We are creating the new calculator, means we are creating the object of calculator class, and this calculator class is a abstract class. Why it is crying? Because abstract class we cannot create the object of abstract class, right? And I have told abstract class is partial. Abstract class is partial abstraction we can achieve. Partial abstraction means what? Partial abstraction it may have abstract method, it may have some concrete method. I have already I can let me write. Let me write a dummy method. Void display. Void display is a method. This is a concrete class. Okay, this is a concrete method. This is a concrete method, and this is a abstract method. So this consists of uh, one abstract method and as well as one concrete method. So I can say abstraction we can achieve through abstract class, that is not that means we cannot achieve 100% abstraction. I mean to say that we cannot achieve 100% abstraction through abstract class. Okay, why? Because we are using we are using like concrete method, and we are using also we can have abstract method also. Okay, okay. You understood what is abstract class with example. Okay, so abstract class can have abstract and non-abstract methods. I have already explained. So it needs to be extended or implements a method. Whenever we are writing an abstract class, what we can do, whenever we are writing the abstract methods without any implementation, whenever we are writing this add method, before we have provided the implementation, it was returning some addition of a and b. So what I am doing, I am only returning on here I am doing only I have written the abstract method without any implementation inside it. Implementation means we have to provide the curly braces, inside that curly braces we have to write the implementation. So since this class is abstract class, whoever wants to implement this add method, this is an abstract method. So for example we want to, okay, let me show you this. Okay, let me show you this. uh, okay, okay, fine. This is the two things. Let me write the class, for example class addition. Class addition, extends. I have already told whoever wants to provide the implementation to this add method, this is a abstract method. We want to, here what we are trying to do is we are trying to provide the implementation to the add class in addition method. So addition class should extends this calculator class. Okay, class calculator. Okay, so why it is crying? We have done the extend keyword from the calculator class, but we have not given the implementation to this add method. That is why it is crying. What we have to do? We have to implement methods, right? We have to implement methods. So now, what is this? Okay, okay. Create constructor. It is having also constructor. Okay. So what I am writing here, I have written the what I have done. I have provided the implementation here. I want to try like int add, then I want to add a plus b. Okay, return. I just want to return that whatever the implementation we have done before, the same thing I am doing here in the subclass. This is called subclass. I will explain this as part of inheritance, but for the time being, just remember whenever we want to provide any implementation to the abstract class, then we have to write another subclass by extending from the abstract, and in that abstract class, in the subclass, we want to provide we have to provide the implementation, what is the provide to the implementation to the abstract method. Okay. Okay, just understand that. I will explain with example later. The abstract class can have constructor and static method also. I have already shown. Okay, this is the abstract class. This is having one constructor, right? And static method also we can show. We can write. Okay. So now let's learn about interface. Interface in Java. What do you mean by interface in Java? So I have discussed abstraction, right? There is two ways to achieve abstraction. One is through abstract class and another one is through interface. So through interface we can achieve 100% abstraction, because all the whatever the methods we are going to write inside the interface, all are public abstract by default. Whether you write the method name itself, compiler is going to write the method as public abstract. If you write the simply if you write void display method, the purpose of the display method, that will display some dummy message, some methods, right? Some method if you are writing, so the compiler, what it will do, compile, whenever you compile your Java class, what compiler is going to do is, like, compiler will convert that method into the public abstract. Whether you have provided while whenever writing the methods, whether you have written that public abstract or not, it will convert that. Similarly, I will explain that part. Okay, for the time being, let's understand interface is another way to achieve abstraction. So by interface we can achieve abstraction. Okay, so let me tell abstraction. Similarly, whatever we are writing, the class contains some data members like members, constructor, and all these methods, everything. So similarly to class, interface is like a class only. Okay, for that what we can do, it can contain static constant and abstract methods interface. Okay, and in abstract class I have told that we cannot create the instance of the abstract class. Okay, similarly for the interface also we cannot instantiate the interface. Okay, I will explain through an example. Let me write that. Let me first write in the id, then I will come to the theoretical things, right? Let me use that, this one. Let me create one interface called animal. Okay, interface called animal I have created. Okay, good. To create an interface, we have to, through the keyword interface, we can create the interface followed by the interface name. Animal is the interface name. How we are writing the class. Similarly, interface is also interface. We have to write through the keyword interface, and the this one, the animal is the interface name. So this animal interface can contain methods, right? So behavior, which we are calling that behavior. Okay, behavior means like the methods in Java is called behaviors. Okay, so animal, an animal, what kind of behavior an animal can have. Okay, so I can say void make sound, just a dummy method to illustrate this concept. I am taking the method to demonstrate the concept only. Don't concentrate much on the logic. Understand the concept, what I am saying, what I am explaining, right? It's a make sound is the method. If I write the implementation to this method, then I have to provide inside the curly braces. As soon as I provided the implementation, I am writing the curly brace means I have provided the implementation to this. Whether I have written any logic or not is that is separate thing. But if I write the curly braces means we have provided the implementations, right? As soon as write the implementation, this method is crying. That means we cannot provide implementation to the abstract, sorry, into the interface. Okay, so over on this method interface abstract method cannot have body. It is displaying interface abstract method cannot have body. Okay, So whether if you write the abstract or not, it will consider as a abstract method. If you write abstract void make sound, this is similar to if you don't write also, if you remove this abstract keyword, then it is also going to be a abstract method. The signature, if you don't write, what the compiler is going to do is it will write public abstract. This is the things the compiler is going to do. Okay, this is the things. For time being, let me only write the this one. Make sound is the abstract method. Okay, only abstract method. And let me take another method also. Void animal can have run. Animal can run, right? So this is also a abstract method. Okay, this is the two things I have written. So uh, let me provide the implementation for this, right? For example, we have a class, any class that will provide the implementation to this interface. That class needs to, for the inter for if a class inheriting from another class, then that time we are writing the extends keyword to provide the like class A extends from the class B. But in case of interface, what we are going to write is, for example, class not dog, like let me take as lion. Okay, lion is the class which will implement, because animal is a interface. If you are going to write an interface, then we should use the keyword as implements. Okay, if it is a animal is a class, then we should use as extends. Okay, that is the difference from class and interface. Okay, so as soon as we wrote lion class, lion is an animal, right? So is why we are writing it implements from animal interface. So as soon as we wrote this implements animal, then it is giving me error. Why? Because whatever the abstract class we have, interface only contains abstract methods, right? Abstract methods. We have not provided the implementation to these abstract methods. So it is mandatory that whenever you are writing any interface, and you are implementing that interface in the subclass, then in that case mandatorily you have to provide the implementation. Okay, so let me provide implementation. Implement methods. Okay, these two methods. Just write sys out. Make sound means lion. What sound lion can have? Roar. Okay, lion is roaring. Okay, and for this run method, just to check run method. Uh, oh, okay, lion is running or running. Simply running. Okay, these are the two things. Okay, I have what I have written. Just concentrate. This is interface only contain abstract methods only, and for that implementation, if you are implementing the in the sub in a class that interface, then we are bound to implement whatever the methods we have inside the interface. We are bound to implement, otherwise we cannot compiler will throw error. Okay, so let me write the test class. Okay, class test animal. Okay, test animal. Just I'm writing test animal. So in that, let me write the main method. Okay, we have studied in abstract class that we cannot instantiate the abstract class. Similarly, this is the animal class. Let me write instantiate the animal is equal to new animal. Okay, if I write new animal, then what is the issue we are getting? Because we cannot instantiate animal interface. Animal is abstract, cannot be instantiated. Okay, animal is abstract. So since it's a interface, so we cannot instantiate the animal. Similar to abstract, we cannot instantiate the interface. For that, what we can do? We can write the implementation. implementation is nothing but lion. We can write like this. We can hold the child class object with the interface variable, interface reference. That we can do. We can create this one, and instead of animal directly we can write lion also. But this is also fine. But we can reference. It is a good practice to always write, always create the object and hold with interface reference. Okay. Then what I can do, we want to create we want to call that method animal dot make sound. If we call, then and next method animal dot run method, run method also we are writing. So these are the two methods we have. What I have created, I have created the object for the subclass, that is lion class, with the inner and holding that lion object with the reference variable of interface. Okay. And I'm calling the method of the subclass, right? Like calling the method this one. I will explain. Just remember, this is some concept is there related to this one. I will explain as part of inheritance, but for the time being, just remember that we cannot instantiate that interface, and this is the way we can call this method, right? Let me run that. Okay, we got that row and running. Okay, that's fine. Let me switch back to the theoretical things. Okay, so we have that interface in Java is a blueprinter class. It has only static and constant and abstract methods. Interface is used to achieve abstraction and multiple inheritance in Java. Okay, now why we use interface? Interface is used to achieve abstraction. I have already told, through abstract class we can achieve abstraction, and through interface also we can achieve abstraction. In the case of abstract class, we are achieving uh, abstraction, but not 100%. Partially we are achieving, because the abstract class can contain uh, concrete method as well as the abstract methods. But in case of interface, we are only having the abstract methods. That is why we are achieving 100% abstraction in case of interface. Okay, and multiple inheritance I will cover as part of inheritance, but for the time being, just remember, if we have more than two interface and we are writing a class implementing from the interface, then in that case we can say, for example, interface B is there, interface C is there, and class A is there. Class A implements from A comma B. That means implementing from interface A as well as interface B. In that case, we can say it is comes under multiple inheritance. That means the relationship is multiple inheritance. And that, just remember, multiple inheritance in Java we can achieve through interface only, and multiple inheritance we cannot achieve through classes. Okay, I will, for that I have in later point I have a detailed explanation why we cannot achieve multiple inheritance through classes, but why we can achieve multiple inheritance through interfaces. That I have a separate discussion on that. For the time being, just remember, multiple inheritance we can achieve only through interface only, not through classes. Java does not allow in multiple inheritance through classes. Okay, interface I have already demonstrated as part of the example, but here the theoretical things I am covering. Interface cannot instantiate just like abstract class. Okay, all the methods in an interface are declared with empty body. That means all the methods what that is there in interface, by default it is abstract. Okay, without having any body, and all the fields are public static final. If you write int number is equal to 5, that means the compiler is going to convert that variable as public static final number is equal to 5. That is a constant. Whenever you write any variable inside the interface, that is by default is a constant. Okay, and all the methods are public abstract by default, whether you write or not. Okay, then as part of implementation interface, I have already told that implements keyword we have to use whenever we are writing the implements. a class implement the interface. Okay, and Java 8, I have explained the interface only contain up methods, but provided to the condition that see till Java 7. From Java 8, we can an interface can have default and static method as well. This is from Java 8, and there is a another version that comes in the Java 9. An interface can contain private method also. That Java 8 and Java 9 I will discuss in separate video. I have started with the playlist called Java 8 features. You can check it out. There I will cover this point. What is the Java 8 features? What do you mean by default method? What is the static method in an interface? And how we can write the means in Java 8, Java 9 there can be private methods also. An interface can have private method as well. That I will discuss as part of Java 8 features and Java 9 features. Okay, so you can check my playlist as well for Java 8 features. Okay, so now it's time to declare the interface. I have demonstrated with the example. Just see what is the declaration for an interface. So whenever we are writing the interface, then the interface keyword we need to use followed by interface name. I have given the example of animal. I have written the interface animal. Okay, and the methods and the fields you can write similarly. Okay, and what are the reasons to use interface? So you have studied what is the interface and what are the things we can achieve through interface. I have already discussed with the examples. Now then if you are working with the interface, then what is the reason for using the interface? Then by using interface I can say we can achieve reusability, and we can get abstraction, right? We can achieve abstraction through interface. So interface is used to achieve abstraction. I have told already 100% abstraction will achieve till Java 7. Okay, interface is uh, right. I have told interface is used to achieve loose coupling. So whenever we are writing the interface, by using that we can achieve loose coupling. And the third one is like by interface we can support the functionality of multiple inheritance. I have already explained this part, right? So I have explained in the code that what compiler will do internally. I have explained if you write the variable inside the interface and the methods inside the interface, then what is the thing that compiler is going to do internally. For example, let's take an example. We have a sample.java interface, right? Sample.java is the interface which is having one int value is equal to 10, that is a constant one, and void display is the method. Display is the method and value is 10. This is the two things sample interface is having. Okay, and we have not written anything apart from that. Okay, so if we compile this interface, then what the compiler is going to convert, right? Compiler will convert into something like this. So the variable is something public static final, and int value is equal to 10, and the method is public abstract. Okay, these are the things compiler is going to add by default. Okay, so I have already discussed to achieve abstract. Two ways we can achieve abstraction. One is abstract class, another one is interface. To summarize the all the things, so I have kept this point. What is the difference between the abstract and interface? So I have already told abstract class and interface we can achieve abstraction from these two concepts. Okay, I have already told, and we cannot instantiate in case of abstract class and in case of interface, but still some difference are there we are going to learn here. Okay, that is, the first point is abstract class can abstract and non-abstract methods. I have already explained these things. Okay, but interface can only have abstract methods only. Abstract class does not support multiple inheritance. Interface because why abstract class doesn't support, because it's a class. I have already told Java does not support multiple inheritance through class, but Java supports multiple inheritance in terms of interface. Okay, through interface. Abstract class can have final and non-final, static and non-static variable, but interface has only static and final variables. Okay, and abstract class can provide the implementation of interface. Abstract class can provide the we are in interface. By using one abstract class, we can provide the implementation to the interface. Interface having the abstract method and only abstract method, and in abstract class, what we are going to abstract class can contain concrete methods as well as the abstract method. But if you write abstract class which will implement one interface, then in that in abstract class we can provide the implementation to the interface. The point is saying, fourth point is saying that. Okay, but in case of interface we cannot provide the implementation to the abstract class. We cannot provide because it's an interface. One abstract method will be there, so we cannot provide the implementation. Okay, the abstract keyword is used to declare the abstract class. I have already discussed. To summarize, I've just kept this difference. Okay, the interface keyword is used to declare the ends. An abstract class can extend another Java class. Okay, and implement multiple Java interfaces. A class, whether it is an abstract class or it's a normal class, that class can extend another Java class, but implement multiple. It can implement multiple interfaces. But in interface can extend another Java interface only, not the class. Interface can extend only interface. Okay, an abstract class can extend using the keyword extend, and interface using the implement using the keyword implements. I have already discussed. To summarize all the things, I have kept this difference. Okay, so that interface and abstract class will be there in your tip of your tongue. Okay, a Java abstract class can have members like private protected, but in case of interface, only interface members are public by default. Okay, these are the differences we have understood. Okay, so this is a very important concept as part of OOPS, abstract class and interface. Definitely, if you are going for an interview or the whatever, you are going to get these questions. What is the difference between abstract class and interface? You have to remember, I have already demonstrated with the examples. You have to write the code, you have to remember all the things, and you have to explain. Okay, now it's time to explain encapsulation in Java. What do you mean by encapsulation in Java? That is also a very important feature as part of Java. Oops. Okay, so encapsulation means what? Encapsulation means wrapping the data members into a single unit. What do you mean by wrapping up data members? Data members means variables and methods we have. We are what we are doing? We are putting all together data members into a single unit through the class. We are writing the class. Inside the class, what we are writing? We are writing the variables, we are writing the methods, whatever we are writing inside the class, we are wrapping all the data members inside a class. Okay, that is nothing but encapsulation. Okay, okay. Then how we can achieve encapsulation? We have the data members. In order to achieve encapsulation, what we need to do is we need to write the data members of the class as private. By writing the private specifier, we can achieve encapsulation. Let me as like interface, let me take the example, then I will come back to the theoretical things. Okay, then only you will understand it more easily. Okay, for that let me take one example called let me tell me one example what I have to take. Let me take one example. uh, Employee is a class. Employee is class. Okay, what I want to do, it's employee can have emp id. Okay, employee is having one id. and string emp name. Okay, these are the two things I have for a class employee. So what I am writing, I am writing employee id and employee name. By that, we are not making our data members, whatever the variables we have for this employee class, we are not making like something anybody can access these things, these data members, right? So for that, outside this class, but in order to make achieve encapsulation, what we can do, we will write private before that, private int employee id, so that we are what we are doing by providing the private, what we are doing, we are restricting this employee id and employee name of the employee object. We are restricting, nobody should access these data members outside the employee class. That is the job of encapsulation. Okay, whatever we are writing the members inside the class, that means we are restricting the access of data members outside this employee class. I hope everybody is clear, right? Okay, and the very next question comes into my mind is, the interviewer will ask, if you explain these things, we can restrict the access of the data member by providing the access specifier as private outside the class. Then if you are writing the private, then outside the class, how we are going to access these data members? If you not provide the access to for this data member, then there is no need of using this class, right? This class is useless, I can say this employee class useless, right? Why? Because there is no way to access this member variable. If you are not able to access this member variable outside the class, then what is the purpose of writing this employee these variables, right? These data members, right? So let me, is not it? Let me write one class that is test is not there. Okay, let me write the test class. Okay, this is a test class. Let me write the main method. If I write the main method, in order to access this employee class, what I need to do? I need to create the object. How we will create the object? Employee is equal to new employee, right? This is the way of creating object or not? We are creating the object of employee by using the new keyword. I have already explained, right, in the previous video. In the I think in the beginning of this video, right? Okay, so what we are trying to do here is, we are trying to employee dot for example emp id or emp uh, emp name is equals to it's a string. Let me write is as Prakash. Okay, what we are trying to do, we are trying to set the employee name to Prakash. Okay, we're trying to set the employee as Prakash. Okay, so but we are getting some error here. Why? Because let's just hover on that. Will say it is saying employee name has private access in the employee class. Okay, that means whenever you are writing the private, you are restricting restricting the access of this variable outside this class. I have already told. That is why it is giving issue. So what we have to do, we have to provide some way to access this. For that, what we can use getters and setters. What is the job of getters and setters? The job of the getters and setters, what is that? What are they? There are methods. That are the getters and setters methods. By using the getters method, we can get the data of this variable, and using the setter methods, what we can do, we can set the data for this employee id. Okay, let me provide the getters and the setters. Okay, okay, for these two. So I have written getters and setters. Now come down, let me remove these things. Okay, this line is giving issue. So what I can do, on the employee object, what I'm trying to do, I want to set the employee name as, for example, Prakash. Okay, I have written Prakash. Okay, then employee dot set employee id. Employee id is 101, for example. Okay, I have written these things. So for that, let me, for the to display that, let me write the toString also. uh, toString for that, in order to display that. Okay, let me write sysout employee object, right? Employee. Okay, just trying to let me run that. What I have done, I have set the value for this employee name and employee id. Explicitly I have set here, right, with the hard coded value. This is the hard coded value I have passed, Prakash, and this one. Okay. Okay, we got this employee id is 101, employee name is Prakash. We got. Why? Because we have provided the setter method to this employee class. We can set. Okay, not only this, what else we can also do? If through the encapsulation, what we can do, not only we are getting the security, means we are providing the we are restricting the access by providing the private specifier to these variables, right, data members, right? So that means we are restricting, means we are providing some kind of security. So no no class can access these data members outside this class. Okay, so for that purpose only we are using private. We have provided the method getters and setters so that outer class can access these data members. Okay, the security, for security reason we have written. So whenever we need some what I can say, some sensitive data, we want to we want our data members should have some sensitive data. In that case, we can write our class through encapsulation. Okay, this is the things. And one more use case I want to discuss here also. So for the setter, for example, let me take one set employee name. For this employee name, one condition I just wanted to implement. If this emp name, uh, if this employee name is equals to null. Okay, employee equal to null, or or employee name dot is empty. If it's if it is empty, okay, and if it is empty, or if it is null, then what I want to do is, what I want, throw exception I have not taught, but what my intention here is, I just want to validate, means someone should not set some ugly data, right? So for that, first thing we got the, we are using the encapsulation for the security purpose. And if we want some more validations, here we are trying to validate if the employee name is null or employee name is empty, then simply throw new illegal argument exception. Illegal argument exception, and just pass the message that, okay, employee name should not be empty. So not be empty. Okay, this is the message we are trying to tell. What is the purpose of writing this validation? If so that whatever the class is trying to access our data members, through the data members, though we have provided the setters and getters to access the data members, no one should set the ugly data. Okay, so in order to restrict, in order to validate that, I have provided these things. Set if the name is empty and these things and employee name is null, then simply throw the employee name should not be empty. Okay, we have just provided this one. Let me send the empty, set name as empty. Let me try to run this. What is the output going to get? Definitely it will throw the exception since we are setting the employee name as empty, right? Okay, as expected we got the exception in thread main. Illegal argument exception for employee name should not be empty. Whatever the message we have written, that message is showing. So the end user can easily understand that the employee name should not be empty, so that employee end user will be like conscious that like we should not send the request without specifying the employee name. There we need to specify the employee name. Okay, so this is a validation things I have explained. Now let's switch back to the theoretical things. Okay, we can use setter and getter method to this one, set and get data for the data members. And what are the what are the advantages of encapsulation? Now what are the advantages we will get? We will get data hiding, because by providing the private to the private specifier to the data members, we are indicating that we are restricting the data members from the outside of the class. Okay, we are hiding our data. Now through encapsulation we are also achieving abstraction, right? What is the job of the abstraction? Job of the abstraction is to hide the internal implementation. Here also we are hiding the internal implementation. I have just given the example, the set name. Inside the set name method, what we are doing, I have specified some more logic, right? If the employee name is null or empty, so should throw some error. So whenever some outside class, someone is trying to access or trying to set the value for the employee name, then he or she don't have the knowledge that the internal logic should be has written something like this. We have provided the setter and getters, so outside the class he or she is only setting the value. He don't know the internal implementation. So by encapsulation, not only we will we will get the data hiding, also we will achieve abstraction as well. Okay, so by writing the code, it is easy to test. The encapsulation class can be tested easily. Okay, and read only and write only. Okay, so what we are doing by setting the employee name, employee ID, what we are doing, we are editing, we are setting the data, means we are writing the data to the data members, right? If the writing the data, if you are able to write the data through the set methods, then how to achieve read only? In that case, what we have to do, we have to if we don't write the setter methods for the employee class, then it will become only read only. Okay, by providing the by omitting the setter methods, we can get the read only. Okay, and write only also similarly we can have, and control over the data. So what you are doing, I have implemented one some validation code, right, in case of set employee name. So similarly what we are doing, we are controlling the data. So next thing is control over the data as per our need. In the employee class, what I have done, I have written the extra code for the validation for the employee. So we have the control over the data. So whatever the things we want, we can implement that inside our setter method, sorry, setter methods, right? So whenever I have written already the implemented code, I think this concept is clear to everyone, right? So I have written the employee class example. Okay, fine. So I hope everyone is clear regarding the interface as well as the encapsulation so far, right? Whatever the things I have explained. Then I have already explained the why do we use data hiding. I have already explained the security things, right? By providing the private, we are securing our data, and also by writing the external additional logic, we are securing our data more efficiently, right? These are the two things we can do as part of encapsulation. If someone will ask you, right, why do we need encapsulation? You can say for providing the data hiding, for providing the data security, we are using the encapsulation feature, right? And you can give the example as well. For example, we have an employee class, we want to hide the data. For that, we will provide the private uh, data members, right, to hide the data members outside the class. And for the security reason also private. And if specific some security you want to provide, in that case also you can provide the implementation inside the setter methods, right? How I did for the employee name, right? Similarly you can hide the data, right? These are the things we have covered. Okay, so we have covered abstraction, after class interface, and then we have covered encapsulation. Now the two things are pending, that is inheritance and polymorphism, that we are going to cover. Okay, so next we will cover these two things. So now let's explain inheritance in Java. So what do you mean by inheritance in Java? So inheritance in Java is a mechanism by which one class is allowed to inherit the feature. That means one it's a mechanism by which one class is allowed to inherit the feature. Feature means what? Feature means field and methods of another class. Well, consider two class, class A and class B. Class B is inheriting the properties or features from the class A, fields or methods. Then that concept or that mechanism is said to be inheritance. Okay, okay. So uh, this inheritance we can achieve by using the keyword extends or implements, right? In case of classes, how we can do? We can implement, extends one class from another by using the extend keyword. Though I have explained these extend and implements in interface and in case of encapsulation, that is actually part of the inheritance. So though that is required, that was required at that time, so I have explained with examples. Now I am explaining in case of inheritance. So that using that implements and extends keyword, we can implement that inheritance, right? So why do we need inheritance? We need inheritance for the purpose of code reusability. What do you mean by code reusability? So I have explained what is the inheritance. So one class is trying to inherit some properties, the fields and methods. That means whatever the fields and whatever the method that is there in the superclass, that is going to be inherit. Sorry, I should not use the superclass, from one class that is inheriting to the to another class. That means the same code that is there in case of one class, class A, that is inheriting to the class B. Okay, that is the code reusability. Before going further, let me tell you the class from which we are the class A is in the class B is inheriting some properties from class A. So in that case we can call class A as the base class or parent class. Okay, and class B as child class or derived class. Okay, child class or derived class. So these are the concept we should remember, that is a parent class or base class, child class or derived class. These are the different names we can think of. Okay. So here we are going to use superclass and subclass throughout this inheritance. Okay. So the code usually the code written in the superclass is common to all subclasses. The code which, because by property of inheritance, subclass is going to inherit all the property of means the property, or not, I cannot say all the property, I can say the property of the superclass. Subclass is going to inherit the properties of the superclass. Okay. So by that we are achieving reusability. For example, we have a method in class A. Okay, whenever we write class B extends from class A, then we are what we are doing, whatever the method that is there in A class, that is also whenever we are extending, that is a part of that method is going to be a part of B class, because we are doing the inheritance. Okay. And method overriding. So by using inheritance we can achieve method overriding. Okay, what do you mean by method overriding? Let me give you the brief idea. What do you mean by method overriding? For example, there is a method in the superclass, and base class we are writing the whenever we are extending base class is extending from the parent class, then whatever the method that is there in the base class, that is inheriting to the subclass. Okay. So and that and we are providing the implementation, some implemented, not implementation, if we are writing the whenever we are implementing, then that is a part of our subclass. That method is a part of subclass, and we are writing some code inside that method. In that case, what we are doing, the same method we are trying to reuse. That method we are trying to reuse means what we are doing, that is the feature of overriding. We are overriding the method of the parent class in the subclass, that is the child class. Okay. So another concept that is related to overriding is we can achieve runtime polymorphism by using the override principle. Okay, I will explain what do you mean by runtime polymorphism going further. Okay. And to achieve abstraction also we are using inheritance. Okay, let me explain. I have already explained what do you mean by abstraction, abstract class and inheritance. Whatever the abstract class method we are writing, that implementation we are providing in the child class. If you remember, animal class I have given example, abstract animal class, and there some property like make sound is the abstract class, abstract method. Then for that, if we are writing the dog class, and for that in the dog class we are implementing that make sound method in the dog class. Okay. So by using the dog class extending from the animal class, that is abstraction. Just like inheritance, so we are achieving abstraction through inheritance. That is the things I wanted to explain. Okay, I think all the things which I have given above, that is clear for everybody. Now what are the terminology using inheritance? I have already told one terminology, that is superclass and subclass. Okay. I have already also explained, right? Then how to achieve inheritance? We can achieve inheritance by extend keyword. The extend keyword indicates that you are derived from an existing class, that I have already discussed. Okay. And class derived class extends base class, that is also I have explained. Okay. Then now the point comes is, how many types of inheritance are there in Java? Okay, in Java there are different kinds of inheritance there. Okay, I will explain one after another. Like there are multiple types of inheritance, like single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance. All these are there. I will explain one after another. Okay, let's talk about single inheritance. What do you mean by single inheritance? Okay, when a class inherit another class, it is known as single inheritance. For example, think of a base class. Think of a class that is animal. Animal is having make sound method, and in the base class is the dog class, which extends from the animal class. That that relationship we can tell that is a single inheritance, because dog class is inheriting from one single class, that is animal class, that is comes under single inheritance. Let's here is a pictorial representation of single inheritance, that is B class is extending from A class, that is B class inheriting the properties of A class, that is comes under single inheritance. Now now let us know now multi-level inheritance. What do you mean by multi-level inheritance? As I told, single inheritance, there will be two class will be there, one class will be extend from the another class. Since the name suffice that multi-level inheritance, that means there will be more than two classes, right? Then I can say, if the class are in level, one level after another level. Let me take one example. If a class A and class B and class C class extending from B class extending from A class, then in that case, I can say all the A, B, C classes are in multi-level inheritance, because the level I'm seeing that there are two levels, right? C is inheriting from B, B is inheriting from A. That means I can say these are all in a this A, B, C are in multi-level inheritance. Okay, chain of inheritance. Okay, so I have explained like base class, intermediate class, and derived class. Okay, so A class is the base class, and derived class is the C class. C class is inheriting from B class. That is the intermediate class, which is inheriting from A class, right? I think this, I hope this is clear to everybody. Okay. Now, the concept of hierarchical inheritance. What do you mean by hierarchical inheritance? Okay. When two or more classes inherit a single class, it is known as hierarchical inheritance. Okay. Two or more. For example, let's consider one example. A class is there, B class is there. Okay. A class is there, B class is sorry, A class is there, B class and C class is there. Okay, and B and C extending from A. In that case, so B and C extending from A class. Then in that case, I can say it's in a relationship like I can say it's a hierarchical inheritance. We have one base class. You can see in the picture diagram, like base class A class is the base class. From base class A, B class is inheriting A class, C class is also inheriting from A class, D class also inheriting from A class. So this kind of structure is known as hierarchical inheritance. Okay, clear? Then multiple inheritance. Multiple means what? Multiple means there will be more than one parent class, out of which from parent class one base class will be there, which will be extending from the two base class. Okay, I hope it's clear. Okay, let's see the example. A class is the base class, B class is the like this is the parent class, this is a parent class. Why I am saying? Because C is inheriting from A, C is inheriting from B as well. But here the twist thing is that in case of in Java, this kind of scenario we will never get in through class. A class can never extend from two parent classes, right? Why? Because I will tell the tell with the example. Okay, I will tell after some time. Just understand, if this is the scenario, then we can achieve that, we can say is a multiple inheritance. Let us consider A is an interface, B is another interface, and C is the implementation class. C is implementing A interface as well as B interface. So we can write C implements A comma B. That means interface we can write. C implement multiple interface a class can implement. We can write, but we cannot write C extends class A and B. We cannot write that. Okay, I will explain why. I will explain in later. Okay, let's consider why multiple inheritance is not support with class in Java. Okay, so let us consider one scenario. For example, we have a class called B and a class called C. Okay, so and B and A and B, A and B having two methods called display method. A is having one display method, B is having one display method. Same method A class is having and B class is also having, and C class is the subclass which extend from A class as well as B class. Whenever we are creating the object of child class C class, then we are calling that method. Then which object it is going to call from which class? Either it is from C class, sorry, A class or B class. Then in that case, we will get the ambiguity problem because the same method exists in class A as well as class B. So in order to avoid that situation, multiple inheritance through classes is not supported by Java. I think this concept is clear, right? Let me tell one more time. We have two classes A and B. C is the subclass which extends from A and B. Let us consider this scenario. Okay, whenever we are calling the method, then at that time the method that is there, the same method that is there A and B, compiler will find the difficulty which method to call. It's an ambiguity issue. Okay, so which method to call? So that is the reason in Java multiple inheritance is not supported in Java. Okay, fine. Okay, let's move on. Next concept is polymorphism. And before that, I have written that one diamond problem, that is the same issue, multiple inheritance. So you can easily understand that is the whatever the multiple inheritance I have told, that is a diamond problem because we are not providing the solution, like because the same method of multiple superclass is having, so it is very difficult to provide the solution. So that is a diamond issue. You can go through like that things, right? And next concept is polymorphism in Java. What do you mean by polymorphism? Polymorphism means what? Polymorphism means uh, poly means many actions. Poly means many, morphism means actions. Many actions. Like for example, in Java we have a method. The same method, if for example we have a add method, it is performing the addition. If the add method performing addition of two numbers, and the same method is performing addition of three numbers, that means the add method is adding 10, 20, 10, 10 plus 20. Another add method is adding 10 plus 20 plus 30. Okay, this is taking two argument and another add method is taking three argument. In that case, I can say this is two method is same, add method, but the way of working is different. It is adding two numbers, it is adding three numbers. Okay, the purpose is adding, but the way of working is different. The same method is behaving differently. Okay, so I can say it's a these two methods are in polymorphism. That means whenever the method is performing the same method is performing different action, then in that case we can say that these methods are in polymorphic in nature. Okay, so I can say polymorphism, and there is one more concept. Polymorphism we can achieve through overriding as well as overloading. Okay, I will tell what do mean by overloading and what is mean by overriding. I will let you know. Okay, okay. Then thing is like how many types of polymorphism there are in Java. There are two types of polymorphism are there. One is compile type polymorphism, another one is runtime polymorphism. And compile time polymorphism will achieve through method overloading. Just remember, I will explain the concept. And runtime polymorphism will achieve through method overriding. And what do you mean by method overloading? What do you mean by method overloading? Overriding, how we are going to work on method overloading and method overriding, I'll explain in detail. Okay, don't worry. Then what is method overloading? Method overloading means whenever there are two methods with the same number, same name, method is having same name but differ in number of arguments, or it may be it may be change in number of arguments, or it may be a change in now type of arguments. Whenever there is a difference in number of arguments or type of arguments or both, anything, any change, then but method name should be same, then in that case we can say these two methods are in two methods are overloaded. Okay, I hope it is clear. I have given the example of R method before whenever I started the polymorphism concept. Then that method I can say are overloaded. Okay, and method loading will happen in same class only, not in the subclass. Okay, remember, I have given this example. In add method is performing addition of two integer, and another add method is adding the three numbers. In that case I can say these two methods add is overloaded. Okay. Okay, then different ways to achieve method overloading. How we can achieve method overloading? Okay, just listen. So how we can achieve method overloading? By changing, I have already told, by changing the number of arguments, or by um, uh, changing the type of the argument. I have taken, let me take, I have taken the two integer type. This is the int b. Now what I can do, I will take another add method which will take argument as int type, and let's consider this is float type, performing the same addition. This is different, int and float. This will be different method, right? Different method. So I can say by changing the argument or by changing the type of argument or both. Okay, anything we can achieve. Okay, and one more important thing is, if we change the return type of this overloaded method. For example, consider this method is having same whatever the method I have written in example 1. Consider that same example I have written, only change is there, the return type. If I change the return type, then compiler will immediately throw an error, right, by saying these two methods are duplicate methods, right? So there will be no impact. Why? Because whenever we are calling these methods, then in that case which method to call, compiler will find ambiguity. So in order to avoid that concept is avoided here in Java, right? So what I can say, if you change the return type of the method, then it is going to have no impact in case of method overloading. Clear? Okay. This is the example I have already told. Okay, and I've already told compile type polymorphism we can achieve through method overloading. So what do you mean by compile type polymorphism? We are writing the overloaded methods, right? Whenever we are creating the object of the class and we are calling the methods on the reference of the object which we have created. Okay, whenever we are writing the class, we have a method, we have created the object of the class and we are calling, and whenever we are compiling that class, then the calling method is going to bind with the method. Okay, at the time of compilation, then it is called compile time polymorphism. Okay, I hope you have not understood. Okay, let me tell you or show you with a picture, right? Okay, okay. Let's consider this picture. Okay, I have a class called calculator. I have one add method which takes two arguments like int a and int b and returning a plus b, and add method which takes three arguments and returning the addition of three numbers, right? And we have created in the test class, we have created the object of the calculator class. On the object reference, what we are doing, calling the, this is the way of calling the method, right? So what we are doing, we are calling the add method by passing 10 and 20. Okay, so whenever we will compile this method, this calling part is going to bind to the two param methods, okay, at time of compilation, and this call is going to bind with the three param methods, right, at the time of at the time of compile time. And whenever we will run, that same method is going to execute. Okay, there will be no change. So it is called compile time polymorphism. Overloaded method are said compile time polymorphism. We can achieve compile time polymorphism by method overloading. Clear? I hope it's clear for everybody, right? Okay. Now it's a time to jump over to the method overriding. I think you can work with the example I have already explained as part of abstract class interface, all these things, right? We have animal class, we can extend, and dog class can extend from the animal class. We can give the implementation, and for the method overloading, I have told that in the we have a calculator class having two methods, add is having taking two arguments, returning the sum of the two arguments, and add method having three arguments, and which returns addition of three arguments. Okay. I have method overloading. I have told, and I believe you can convert into the programming. I have already shown, but for the sake of your understanding, I am telling like you can convert into the programming, right? So let's jump into the method overriding. What do you mean by method overriding? I have told in case of method overloading, we have just seen same name but differ in the type and arguments. I have told that in that is called method overloading. But in case of overriding the method name is same and same in parameter. Okay, the parameter whichever we are passing. For example, consider add method. The method name is add and the parameter is int a and int b. Whenever we are saying that two methods are overridden, then that method name and the parameter is never going to change. The method parameter and name is going to be same, and method overriding will achieve through inheritance. That means in the same class we cannot achieve method overriding. There should be some superclass and subclass relationship. If calculator class is having the add method which takes two arguments, two parameters, int a and int b, and we are writing the addition class. Okay, and we are going to implement the add method in the addition class. Okay, which will provide the implementation like implementation means we are going to modify the that whatever the method that is there. We can do something like based on the if we are like performing some implementation in the subclass, then we are going to we are what we are doing, we are achieving overriding in this case, because the same method, whatever the method that is there in the parent class, same method we are going to work on that, right? I hope this is clear. Let me give one okay, one more thing I just wanted to explain here. The method name and the parameter list both together we call as a method signature. Okay, method signature means, what do you mean method signature? Method signature is method name and the argument list. Okay, all together call as method signature. So in case of overriding, the signature should be same. And what about the return type? If superclass is having the some return type in type, so let me take one example. For example, in addition we are returning add method, we are the superclass is returning some double. Okay, so but in case of subclass, the same overriding method, it may return the same type or the subtype. It should not be higher. Okay, I'm giving the primitive type. Okay, let me consider to the object type. Okay, I have written one after class called animal superclass. Okay, the subclass is dog class. Just correlate. Subclass is dog class. We have implemented the make sound method in the dog class. Okay, I hope we have done this example before also. Okay, the dog class return the method. The dog class method is, for example, whenever we are creating this one, the type is first one. The method type is animal type, for example, and the subclass, the method is return type is uh, dog type, or the method type is return type is what is that, animal type also we can do. The subtype should be the same as super type or subtype in case of method overriding. Okay, okay, fine. Then I have already told to achieve runtime polymorphism, we can think of like overriding. Through overriding we can achieve runtime polymorphism. Okay, I'll tell you with example. For example, we have a class called calculator, and which is having history after class, which is having one calculator which takes two arguments int a int b, returns int as the return type, and which is abstract method. And we have written the addition class which extends from the calculator class, which overrides the calculate method of the superclass. Calculator class is a superclass and addition is a subclass of the calculator class. It is extending from calculator, and it provides addition class and returning a plus b. Okay. And test class, what we are doing, we are creating the calculator object. We are creating the addition object by referring with holding with the reference variable of variable calculator of type calculator after class interface type. Okay, okay. So here what we are doing, the addition class object type is calculator. Okay, a calculator, it can have same type or subtype, means addition, but not higher. Okay. So calculator we are calling, this is the method overriding. Okay, I can say clear. Okay, runtime polymorphism. Runtime polymorphism means what? It's, I can say runtime polymorphism is nothing but the late binding, because whenever we compile our application, in case of overloading, so it binds to the bind to the call method signature, and at the time of running, the same method is going to execute. But in case of overriding, what we are doing, whatever the method we have written, whatever the method we have written, so it is going to decide, whenever we are running the application, it is going to decide which method it should run, right? We have a superclass method and subclass method. Whenever we are calling that, at the time of running, dynamically it is going to bind. Okay, at the time of running. Okay, so it is called runtime polymorphism. Okay. If we create the object of parent class, and we'll call the parent on the method, we'll call the parent object, then it is going to execute from the parent object, right? For example, consider that animal class is not abstract, it is a class. It is a okay, now it may be abstract, right? So whenever we are going to okay, not abstract, it is simply a class. Okay, so if we create the object of animal class, and we will call that on the object of the animal object, the method we will call, then it is the method is going to execute from the animal class only, considering animal class is not abstract. So we are creating the object class animal class object and calling the method of animal class. Okay, so it is going to call the method of the animal class. if we have a dog class which implements from the extends from the animal class, and we are creating the object of dog class by referring the reference variable with the uh, parent type. Then if you call, then at the time of calling it is going to execute the method that is there in the subclass, that is the dog class. So I can say it is we are achieving that runtime polymorphism. But why? Because at the runtime it is it is deciding the binding from the subclass and executing the subclass method. So I can say it is we are achieving runtime polymorphism. Let me take the example. Okay, parent class is having one display method and child class overriding that display method. Okay, so in the test class, what I am doing, I have created the parent object. On the parent object, I am calling the display method. So the display method of parent is going to execute because I have created the parent object, right? Parent, new parents. I am creating the parent object. I am calling on the parent object display method. So it is going to execute from them parent. This is going to display. Okay, but if I create the new child, right hand side you can see, right hand side. Don't see the left hand side. New children means this children method means child class object I am creating, and but I am holding with the parent class. That is different. I can hold with the um, uh, parent class reference, or I can hold with the subclass means the child class reference, right? Anything is fine, but you always see the right hand side. What is the object we are creating? Object is child object. On the child object sub object we are calling the display method. Whenever we run, the display method of parent class will not execute. The display method of child is going to execute. This is what we call is a runtime polymorphism. I hope this is clear. Okay. So why it is called runtime polymorphism? I have already explained. Okay. So at the time of whenever we are running this the method at the right runtime at the time of running dynamically, the JVM is uh, going to choose which method JVM should run. Like whenever we are calling the method, which method from where the method should run. That is dynamically decided. So that is why it is called runtime polymorphism. At the runtime, where the JVM is going to decide. Okay. So then rules for method override. Now let's understand what are the rules we should follow while working with the method overriding. Okay, so the rule one is overriding and access modifier. The access modifier for an overriding method can allow more but not less. For example, that means we are writing one method, right? We are writing one method, there should be some access modifier. For example, we are writing one method called private method, right? Private method, we have written one private method, right? So whenever we are we are for example we are writing protected method, right? So protected method we have written means, so that method, whenever we are overriding that protected method inside the subclass, then that access specifier should be higher than protected. Okay, that should be protected or public. Similarly, like whatever the in the simpler term I can say, whatever the access modifier we are defining in the superclass, that access modifier should be same or more than that. Okay, not the not less, but not less. Okay, so if you are writing a protected method, then but you are providing whenever you are overriding the method in the subclass, if you change the return type, sorry, what is the specifier modifier into private, then compiler will throw an error. Okay, because you are restricting that and that means we are restricting the modifier into the lower but less but not higher. Okay, for example, if you are providing protected as a modifier for a method in the superclass, then in the subclass that method modifier should be public but not private. Okay, it may be protected or it may be public but should not be private, because private is uh, less visibility than protected and public, right? You know, that is the what are the modifiers, modifier details, right? You know, I no need to explain. I have only explained what is the rule, right? Then rule 2 explains that final method cannot be overridden. If we have a final method in the parent class, then in the child class we cannot override that final method. Okay, that is the rule while overriding, because Java doesn't allow to override the final method. Okay, that is the rule number 2. Then rule number 3 talks about static method cannot be overridden. Okay, if you try to override the static method, then it is called as method hiding. That is why static method cannot be overridden. Okay, if you try to override, then it is called as method hiding, not method overriding. Okay, then rule 4 is private method cannot be overridden. Okay, these things I was trying to tell. Whenever you are writing the method, that method is private, that means you are restricting the access. I have told you in case of while explaining the encapsulation, right? You are writing private, that means you are restricting the fields or the method, so that outside the class no one can access the fields or methods, right? So in case of overriding, if you write the private as a method, that means if you make the method as private, then that cannot be overridden in the subclass. Okay, you should remember that. Rule number 5, the overriding method must have same return type or subtype. I have already discussed the method return type. For example, we are having a add method. Add method is having can return, for example, superclass returns double. Subclass may return double. If you are overriding the add method in the subclass, then that return type of the subclass should be double or less. That means we can take it as int also it will work, because the return type is the subtype of double, that means int. Okay, so in case of return type, it should be same or subtype. Okay, then rule 6, invoking overridden method from subclass. So the concept here is, whenever we are overriding one method of superclass in the subclass, how we can call the superclass method. In the subclass method, whenever we are overriding, then inside the subclass we will write super keyword. Then it will call to the super method. Okay, by using the super keyword, we can call the superclass method from the subclass. Okay, then rule 7, overriding and constructor. Okay, so constructor, what do you mean by constructor? Constructor is the special method in Java which is having the same name as class name. Okay, which is having same name as class name. But overriding concept is what? Overriding is whatever the method you are writing, the name is going to be same in the subclass. Okay, if the constructor you are going to override, then the subclass name and superclass name is different, right? Subclass and superclass name is different. So the cost as Java is saying, the constructor name be the class name, same as class name. Since the subclass and superclass name is different, so constructor overriding is not possible in case of Java, right? Constructor overriding is not possible. Okay, we cannot, that means we cannot override the constructor. Okay, rule 8, overriding an abstract method. Okay, in abstract method we are writing in abstract class or in interface. That means we are bound to provide the implementation of the abstract class in case of in the subclass. Okay, if in case of after class, if you are not providing, then that class also we need, subclass also we need to write it as after class, right? Okay, fine. Then rule 9, overriding and synchronized or strict FP method. Okay, if you write a synchronized or strict FP modifier with the method, then that is there will be no effect of the while overriding the method, there will be no effect of synchronized or strict FP. Okay, that is straightforward. Okay, then the important feature I'm going to explain related to overriding, related to exception. Okay, what will happen whenever there is whenever superclass is having throwing some exception, subclass what type of exception it should throw. Okay, overriding and exception handling. Okay, there are two rules. If superclass overridden method does not throw an exception, if if superclass does not throw an exception, subclass override method only throw the unchecked exception. I no need to explain what is unchecked exception, what do you mean by checked exception, and the hierarchy I should not tell. You should. I am assuming that everybody should have the exception hierarchy knowledge, right? So here the concept here is like if the override the superclass method is throwing any exception. Uh, um, if the superclass method does not throw any exception, the subclass overridden method can throw unchecked exception or no exception, but should not throw checked exception. If it is subclass overridden method is trying to throw checked exception, then compiler will throw error. Okay. Then rule 2 is if superclass overridden method does not throw an exception. Okay. Subclass overriding method can only throw. Okay, no, if superclass method throws an exception. Okay, if superclass method throws an exception, then subclass overriding method can only throw same or subtype exception. If superclass exception throwing some exception, then subclass overridden method should throw the same type exception or subtype exception. Okay, if 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 the superclass is throwing some exception and subclass overridden method throwing higher the exception that is there in the exception hierarchy what the superclass method is throwing, okay, then that time compiler will give left and right, right? That means compiler will throw an exception. Always remember, if superclass is throwing an exception, then subclass overridden method should throw the same type or subtype to the exception, not not the higher exception, right? Okay, you should remember all these rules while working with the overriding. Okay, so by this I have completed all the OOPS concept, including starting from class, object, abstraction, encapsulation, inheritance, polymorphism, all the concept I have covered as part of OOPS. Okay, I think everybody understood the concept of OOPS in detail. If anybody having any doubt as part of OOPS concept, let me know in the comment section. I will try to explain one more time if anybody is not understood that. Okay, okay, thank you.